We visit websites all the time, probably dozens of times a day without even thinking about it. But have you ever stopped to wonder what's actually happening behind the scenes? Well, today we're going to pull back that curtain and break down all that everyday magic. No, seriously, just think about it for a second. You type something in, hit enter, or you click a link and bam, a whole interactive page just appears. It feels like magic, right? But it's not. It's actually this incredibly well-choreographed dance between computers all over the world. And we're going to break down that entire dance for you, step by step. So where does this all begin? Well, like any journey, it has a starting point. And for a website, that journey kicks off the instant you type in an address and hit enter. That one simple click starts a lightning-fast chain reaction that literally spans the globe. Okay, so let's look at the address itself, the URL. It's not just a random string of text, it's actually packed with instructions. You can see it has a few key parts. First up, you've got the protocol, like HTTPS. This tells your browser how it should connect. And that little S at the end, super important. It means your connection is secure. Then you have the domain name, like developer.mozilla.org. That's the easy-to-remember, human-friendly name for the site. And finally, there's the path, which tells the server exactly which specific page or file you want to see. All right, before we dive deep, let's just zoom out and look at the whole trip from a bird's eye view. It's basically a 5-step process. First, your browser has to ask for directions. Then, something called the DNS gives it the real address. With that address, your browser can request the page. The server on the other end then sends back all the files. And finally, your browser puts all those files together to build the page you see on your screen. Simple enough, right? Okay, now let's dig into each of those steps. Okay, so first things first. Your browser knows the name of the site you want to visit, say mozilla.org. But here's the catch. Computers don't really work with names. They need numbers. It's kind of like knowing the name of a cool coffee shop, but you still need the actual street address to plug into your GPS, right? Same idea here. And that's where something called the DNS comes into play. You can think of the DNS, or domain name system, as the internet's giant address book. Its entire job is to take that friendly name you typed in and translate it into the machine-friendly number the computer needs. And trust me, you're glad it exists. Because without it, we'd all have to memorize these super long strings of numbers just to check our email. No thank you. So, what is that number? It's called an IP address. IP just stands for Internet Protocol. And basically, every single computer or server connected to the internet has its own unique IP address. It's just like how every house on a street has a unique mailing address. This is the real nitty-gritty location your browser is looking for. And this really shows you the whole translation in a nutshell. We, the humans, remember the easy name mozilla.org. The computer, the machine, needs the number 192.0.2.172. The DNS is just that crucial translator in the middle, bridging the gap. It turns the name we know into the number the computer needs. That's it. All right, so our browser now has the right address. It's ready to actually go get the website. But who's it talking to? And how does it talk to them? There are rules to this conversation, so let's meet the key players involved. First up, we have the client, and that's you. Well, more specifically, it's your computer or your phone, and the web browser running on it like Chrome or Firefox. The client's job is really simple, but also super important. It's the one that requests all the information. And then, on the other end of the line, you have the server. The best way to think of a server is as a really powerful computer that's on 24/7. Its whole job is to store all the files that make up a website. The code, the images, all that stuff. And when it gets a request from a client, its job is to respond and send those files back. But how do those requests and responses actually travel across the internet? Well, that's where TCP/IP comes in. It's one of the most fundamental rules of the internet. I like to think of it as the delivery service for the web. It's the truck that picks up your request, drives it over to the server, and then brings all the goodies from the server right back to your doorstep. So let's recap. We have our client, that's us. We have the server, where the website lives, and we have the delivery truck, TCP/IP, to connect them. Now it's time for the actual conversation to happen. So what do they say to each other? Well, they speak a special language called HTTP. That stands for Hypertext Transfer Protocol. It's really just the set of rules for how they format their messages. So your browser will send what's called an HTTP GET request. It's basically the polite, technical way of saying, "Hey there, server, could you please get me all the files for this webpage?" Now, the server doesn't just immediately send the files. First, it replies with a status code, A 200 OK is the one you always want to see. That means, yep, got it, here are the files. But I'm sure you've run into others. That infamous 404 not found? That's the server telling you, sorry, I looked everywhere, but I can't find that page. A 301 means the page moved to a new address, and a 503 means the server's just temporarily down. They're just quick, standard replies, so the browser knows what's up.
Okay, let's say we got the 200 OK. The server is happy and it's ready to send the website's files over. But it doesn't just email one giant attachment, you know? The way it sends the data back is actually way more clever than that.
So instead, all that data gets broken down into thousands of tiny little pieces called packets. And this is a really efficient way to do things. Think about it. If one little packet gets lost on its way across the internet, your computer just has to ask for that one small piece again, not the whole giant file. It's like shipping a massive Lego set. You wouldn't put it in one giant fragile box, right? No, you'd put it in a bunch of smaller numbered boxes. That way, if one box goes missing, you only need to replace that one box. And TCP? That's the part of the system that makes sure all those little boxes arrive and get reassembled in the right order. So what's actually in all those packets? Well, it's the three core building blocks of pretty much every modern web page. First, you get the HTML. That's the skeleton, the basic structure, and all the text. Next up is the CSS. That's the styling, the clothes, the colors, the fonts, the layout. And finally, you get the JavaScript. That's the brain, the muscles. It's what makes the page interactive, with animations and pop-ups and all the stuff that happens when you click. Your browser is like a master chef, taking these three ingredients, putting them all together, and presenting you with the finished website.
And you know what's absolutely wild? This entire journey from your click to a server that could be on the other side of the planet and all the way back to your screen, it all happens in milliseconds, literally the blink of an eye. So I'll leave you with this final thought. This whole process is getting faster and faster every year. So what happens when it becomes truly instantaneous? How is that going to change how we interact with, well, everything online?